Hello, everyone. Hope you are doing great today. My activity is all about volume discovery. My name is Lindsay Bubnick, and I teach eighth grade math. In eighth grade, we focus specifically on the volume of cylinders, cones, and spheres, but this lesson plan is all about the volume of cylinders and cones and making the connections between those things. Now, our standards and learning targets, are focusing on the Kentucky standard of know the formulas for the volumes of cones, cylinders, and spheres, and use them to solve real world and mathematical problems. Well, before we can apply these to real world problems, we have to have a good understanding of these formulas and where they come from. The target for the day would be I can identify algebraic connections between the volumes of a rectangular prism, a cylinder, and a cone. Basically looking at the connections between those things so the students understand where our formulas come from. They're kind of discovering the formulas on their own through this activity. The materials needed, the handouts with guided questions and nets of figures. I have the handouts later on in these slides. They'll need scissors to cut out nets. They'll need tape. Believe me, don't go down the glue route or it's going to be a mess. And cereal and rulers to make some measurements. Now, the lesson setup. In my opinion, it's the best to work in small groups. I have my students in Kagan grouping, and I always think that this works very well, but I understand different personality types want to do things differently. I could see this working well with partners, but obviously somewhere along the line, your students will be needing to communicate with others, so just keep that in mind. Whenever I use the Kagan grouping, I try to assign student roles, things like time monitor, work checker, discussion leader, things like that, just to be sure that everyone has something they're responsible for. What to prepare beforehand, have extra copies of nets. I guarantee you some of your students are going to mess them up and they'll need extra copies. Measure out Ziploc bags of cereals in advance so that way you're not having to go from each table and pour out cereal. You already have it ready to go, and that'll save a lot of time. Differentiation for this lesson, I would recommend doing like a group of students, like your lower level students who struggle, perhaps have them in a group all in like to themselves in close proximity to you so that you can work very closely with them and guide them along, give them that extra little push. For your higher level students, there's actually other connections they can make using different figures and kind of see how all the volumes relate. So you could perhaps do that on some kind of station day just to kind of expand this activity. Procedures. So when I taught this, I just did a little introduction by having them have a bell ringer. It says post students with an opening question that triggers prior knowledge. So my bell ringer was to find volume of a rectangular prism. So in the past, eighth graders should already know they were taught how to find the volume of a rectangular prism. And my students did a very good job remembering, and I did let them kind of discuss the bell ringer together. And for the most part, they remembered. And that's vital because you're going to need to have them know that in order to make connections to the new volumes you're going to be looking at. And that's kind of like what I talk to my students about when I introduce that target. I just say, hey, we're going to use this and build on this to figure out how to find the volume of cylinders and cones. Then I had the students kind of close their eyes and visualize each shape. How are they different? How are they the same? So they can already kind of start mentally making some connections there. And then I had my students do a round robin and we kind of shared out as a class and just kind of made a little list on the board. It didn't take too long. And I wouldn't recommend spending forever on it. Because, of course, your biggest part of the lesson is exploration. Of course, you're going to need to pass out all the materials, and there's a lot of material work, and it's going to take a while for the kids to cut out all of those nets and piece those together. I recommend before you have them start cutting them out, have them make their measurements and see how tall each of the figures are because it's going to be much easier for them to measure them before they start piecing it together. Then you're going to see the sheets here in a second of the guided questions. And you just kind of have to you know how it is with middle schoolers. I'm sure it's the same with any kids. You're going to have to kind of set up some expectations ahead of time, saying don't work ahead because you want to be sure that they're participating in a lot of discussion. Then the students follow directions on each sheet, and I'm going to have to play a big role, or I did play a big role saying you're going to have to play a big role if you implement this activity in guiding your class. I recommend doing a lot of turn-in talks, round robins, and class discussions just to kind of be sure everyone's on the same page. And you're going to have to really help them along on some of the questions but I mean, of course, play the role as a facilitator. And then the assessment would be just a quick exit slip. Now, here are some of the handouts. The triangular prism will actually be used for a different connection lab. The rectangular prism, cylinder, and there's 2 sets of cones that we'll use for this activity. So here is the first handout. It says, compare the heights of the figures. This is once again where that comes in, where you're having to have the students measure those things ahead of time. And they're going to find that those heights are equal. It says compare the areas of each figure's base. You're going to need to kind of guide your students to realizing, oh, we're dealing with circles and pi is possibly a factor in this. So the cylinder's base area should be pi times the rectangular prism's base area. If the rectangular prism's base area is 1 square unit, what would the area of the cylinder's base be? So once again, making that connection of it's going to have to be pi. Then hypothesize how the volumes compare. So the students are going to have to determine what the volume must be like if their base area is like that. And they're going to test the hypothesis in the next question by pouring the serial from one of those objects into the other and kind of see how those compare. And then they need to write those observations. So a lot of exploration, a lot of, thinking ahead and thinking how do these things connect with each other. And then you're just going to kind of go through the rest of the worksheet with them to have them discover the cylinder's volume. And once again, you have to guide them using pi and reminding them of pi. The last one, now we are comparing the area of the cylinder to the cone, and once again, having those things already measured out is going to be very helpful for the students just to quickly compute those. And then, of course, they're going to eventually discover after pouring those things in that the volume of a cone is going to be 1/3 of the volume of a cylinder. Thank you all so much for listening. You have a great day and see you in class.